Hi, Ingo. Welcome back.
Hey Adam, thank you for having me the third time in a row.
Yeah. And today we destroy Java with Kotlin.
Well, I would not say that. I'm not a Kotlin fanboy. I'm not. I primarily program in Java, but I like Kotlin, and maybe I can offer a biased view of
Very good.
why.
Because I'm back from WJAX. This is a conference in Munich last week. And so what I did, sometimes I do it. So I ask the attendees before my talk to ask questions. And of course, the last question was what my opinion about Kotlin. And my opinion is that Java 21 is great. And for me, I like the stuff in Kotlin, but this is not good or not good enough. It is good, but how to call it? The features are not that overwhelming that I'm willing, to leave Java and go to Kotlin. This was my answer. And after the talk, someone else came to me, also another attendee, and he told me so he listed the features, right? And for every feature, I had an answer. So there was like Java 21 or whatever is able to do that, Java records and whatever, and coroutine. So everything was actually, and he said, yeah, but the remaining reason are collections, because the collections in Kotlin are outstanding. And the reason why he actually does Kotlin is collections. So I had no time to discuss the collections, but I said, okay, maybe, but I'm not. I think Java collections are really great. And my understanding was in Kotlin, you can reuse the stream or something like this. I had no time, to fully understand what was the advantage of that. But this was the preparation for the show last week with the Kotlin. And now I understand you do with Kotlin something what I wouldn't expect. So you are actually writing backend code in Kotlin, right?
Yes, interesting about the collections. I mean, I think that would fall into the category of various things that make you more productive or nice about the language,
Mm-hmm.
which are not the main reasons why you would use Kotlin.
Mm-hmm.
Because I would start with why what are the cons really from my perspective to not use Kotlin, and that is basically that, like, everything about tooling, about IDE support, um, is worse than in Java. So that you have not the same experience. Like if you work even in IntelliJ IDEA, then the experience when programming Java is the best. When you program in Kotlin, it's slightly worse. Some things don't really work that way. It's not as polished, and so on. Even though those are the creators of Kotlin, the gap is getting smaller. It used to be a lot bigger, but still, Java has the best tooling, and also in terms of, like, when you use libraries, your build, everything will be smoother if you do it in Java than in Kotlin. So that's a big con. And of course, if you have a project, then everybody on a JVM team knows Java, and not everybody knows Kotlin. So that's really a con for using a different language. And just listing things like this is nicer and this makes me a little bit more productive, that doesn't add up in terms of let's use Kotlin. It can be a personal reason, like just for yourself. You can say, I like to do this. I like to be more productive, and I really like these features, and that's fine. But like for a team, there has to be like a bigger reason to do that.
Mm-hmm.
And what I see, like in Kotlin, is like three big things.
Mm-hmm.
The first thing is nullability. So Kotlin has non-null types by default. And this nullability stuff is really big. It's like having static typing versus dynamic typing in a sense,
Mm-hmm.
because like your program tells you things about nullability, and gives you safety guarantees that are really important for writing safe programs. That's something that we will maybe get in Java, like with Valhalla. They're discussing things like that and so on. That's very interesting right now. So that is maybe something that's going away. That is the first thing. We can also discuss about that. But then there are two other big things. The one thing that you said, just touched upon, I'm writing code for the backend, is the ability to write DSLs. That's something that's in the language. And
Should we talk about the null pointers and nullability a bit?
okay.
because if you I don't introduce too much chaos about that,
Okay.
because I've spent I think whatever I'm doing is mostly backend and usually some CLI tools, but null pointer exceptions are not that common, I would say, and in my world, it's not like we are struggling with it, and if they happen, then it is easy to debug them. So it's not like it is a huge problem for in my world. I think it would be different if I would spend time in bigger Swing applications where everything is singleton. So in my world, it's like request. So there's a request scope, the request comes in, and then everything disappears. It's clean again. So there's maybe a different world a bit. And I have to admit what I'm starting to do. I never did it actually. Is let's say I'm validating the parameters, right? So if I'm validating the parameters, usually what I did is I said, okay, I threw a new illegal argument exception or illegal state exception to signalize the validation is not right. But if you use objects require non-null, internally, an own exception is constructed and thrown in Java, null pointer. So actually the Java throws the null pointer if something is not coming in, right? But a step further, if you do nothing and you just say string dot whatever, what is it, length or size, and you get a null pointer, then you get the best possible experience in Java, because then how it's called, the JAP, you get the advantage of having a nicer errors, so you will exactly see in which line it happened. But if you throw your own exception in this particular case, so you will have to provide a nicer stack trace. So what I'm saying is, it is nicer, but it's not like null pointer exceptions are my biggest problem in backend. Or actually, it's not problem at all.
Right. I mean, it's a little bit like static typing. You can get proponents of dynamic languages. We say like the typing stuff and the casting is not a problem, really, because I do this in a very disciplined way, and I always think about things very clearly, and I write this down, and I have these advantages also because I don't have the static typing. And so in a sense, it's like this, it's this guarantee about the state of the program, about what you're doing, that frees you from thinking about things and being disciplined about things in a certain way, and it makes a real difference. Like when you try it and write some piece of logic, it sort of becomes evident that this is a great tool. And I mean, like the Java designers talked about this. This is a $1 billion mistake to allow null for types and so on, and they will do something about that, and I'm pretty sure, because it's very successful in the Kotlin world, and they're constantly looking at Kotlin like it's a little bit like a lab where they can see whether things work out, whether things are a good idea or not so a good idea, and then they can think about it and come up with something that fits into the Java language. And I think that's a very fruitful symbiosis here between the Kotlin and the Java languages, because like they're both on the JVM, they're very close, they're interoperable, and I think that this nullability stuff, that is something that we will see at some point in the Java language, and it will be a big thing. So that's my personal opinion. Like when I work with Kotlin, when I work with Java, I always have this. I feel a general unpleasantness in Java about not having the nullability guarantees that I have in Kotlin. That's just something that you get to feel when you work about it, and you think it's kind of fuzzy, and why is this not there?
Yeah, so, I believe you, because what I usually do if I let's say in backends, so if I use optionals, for instance, right? So it's kind of the solution of Java on the library level. So usually I use optionals to do more. Not just for type checks, but if you see optional in my code is like optional filter map, flat map, if you have two optionals. So like working like with a stream. And this is perfect because I save a lot of code, because I don't have to check for null. And for instance, if I return optional, I can say, hey, optional map, and I can pass the result of this optional to another method, and only if it's not null. So this is great. But there are other methods where it's just, I'm returning a primitive or whatever. And in this particular case, I'm not using optional because maybe I'm too lazy, but I know, okay, it's not worth. I mean, this would be a false signal because Java doesn't have to. So if you see optional as return type, usually happens something with the optional. If there is no optional return type, it's just a value and no one cares about that, right? So, but if Java had it built in, I'm with you. It would be better, of course. But it's not like if I would switch now from Java to Kotlin, for me, it would be a huge difference, right? This is what I'm saying. If I start with Kotlin, then it's great because I don't have to think about this.
Yes.
But in Java, for me, it is like a signal. Is it sometimes I misuse things to have signals, right? For instance, sealed interfaces, right? So we're introduced to have the exhaustive switches in record patterns and so forth. But sometimes I like to use them just to signalize for documentation purposes. Okay, this implementation are available. If you have the interface, you know what's going on, and it was never meant that way, but it works great because if I'm an interface, I see the implementation inside, and it works perfectly, right? So and similar to optional. Optional signalizes, okay, you will usually see a kind of a stream-like behavior if you follow, the stack trace, the references of the method.
No, I'm with you. This might not be. It might be one of those things where you say this is great about Kotlin and makes you more productive and makes it safer, but it's not a real reason to say let's use Kotlin. But coming to the thing that you said in the beginning, that I'm working in the back end and using Kotlin to there. The main thing right now, what I'm doing right now, is I'm using it to replace view templates with pure Kotlin code. So, like in Java, you don't want to write HTML with a Fluent library or something like that. It will not be visible what the structure of the page is and so on. So the solution is to have a templating language like GSP or FreeMarker or Pineleaf, or I think those are basically it. And then that's like a separate language that you have two things, and then the IDE has to support it and so on, and it's difficult to refactor logic and so on. Everything becomes difficult in this templating world rather than having just Java code. So, but you cannot have just Java code for writing HTML pages because it's not convenient. You will not see anything. You will not be able to take the input of a designer and really put it into your code. And that's where Kotlin has a solution which is really perfect for that, which is the DSL. You can write like custom languages with a tree-like structure in Kotlin. It's a language feature basically. So there is also like an official project from the Kotlin team, a DOM builder library for HTML that you can use to then write your HTML pages in Kotlin. So it will be statically typed code. You can have logic in there. You can refactor methods and so on. And that really works great. And you can take the input from a designer very easily and transform that into your code. And that's something that you probably will never be able, or never is a big word, but like in the foreseeable future, not be able to do with Java. And that is really a reason, for example, you say, let's use Kotlin at least for that purpose. And you don't have to use it for everything. And that's also a great thing about Kotlin. It can work in your project and you can just use it for some particular aspect. And it lives in the same modules and you can compile it all together. And there is like very little friction between the Java and the Kotlin side when they call each other. And so you can use it for certain things, not for everything. And for that thing, that's a particular strength of Kotlin that I would say that Kotlin really is a game changer if you produce server-side rendered HTML. That's my strong opinion about that. I think that's really great. And it's
so what are you doing right now? You're using Kotlin and you use the HTML tags, and behind the scenes is more or less Kotlin methods, right? Type safe. And it builds behind the scenes a valid HTML. This is what I imagine what happens. What Ruby did, I guess, with method missing trick or something like this, right?
Right. There's things that the dynamic languages were able to do with their own features that are then create a lot of other problems that you can have now in a completely statically typed environment.
But this Groovy did it for years, right? This was with the Grails, and this was actually the templating with exactly this feature. This was what Groovy was. No kidding, 10, 15 years ago. It was like, the huge big deal with Groovy, right?
Well, Grails actually didn't use an HTML DSL that way. They had this GSP, which is very similar to JSP. Looks basically the same, and they also have their tag libraries and so on. So it's very much modeled after GSP, also interoperable with that. I know a lot about Grails because we had our website in Grails.
Ah, okay.
So that was like in those years when the dynamic language bandwagon, and we thought, let's maybe, because before that we had a PHP website, and then we said it has to run on the JVM, but which option should we choose? And we chose Grails and with Groovy, and that was there were lots of problems, and we really didn't like it, but we invested a lot of it, and we had a long time.
What problems do you have? Because I'm really curious, because I use Groovy a bit, but it was the same argumentation, why I'm not using Groovy, right? So this was, I always ask about that, and I still use Java. And what I know is with the method missing and and they try to replicate what Ruby did with the type safe parsers kind of, and the entire trick was Groovy assumed that there was a method like a tag, and there was no method. But if you pass, what's missing to a generic method error handler, basically, they were able to reconstruct everything in memory, more or less.
Exactly.
So which problems you had with Grace? I'm just curious. We can talk about it because I think, with Grace.
So I personally really just like dynamic typing. So that's dynamically typed languages are nothing for me. I totally respect that there are people who like that, who are productive in that environment, who want to live in such an environment, but I don't. I think that's everything's wrong about dynamic typing for me when I use it. There is no IDE support. There is no code completion, or at least not a reliable code completion. It's something that the IDE can guess somehow and so on. So that's a world where you have no arms or legs or something. And that is really, I think it's a terrible situation, really, and you have to get into a statically typed, or I have to get into a statically typed environment. And also it was like, I'm also a Gradle user, and I really disliked it all the time until they had the Kotlin DSL. Now they have the Kotlin DSL. Now it's statically typed. Now it's bearable to write Gradle scripts. I think it was terrible before that. You had no access to what is behind the scenes, as you said, with the method missing stuff, and it's just happening magically inside somewhere. You cannot navigate to the source code, and it's important to have the kind of help that the IDE can give you, and you know what this method does. So there should be no magic, really, in a program. That's what I like about this. So yes, that's I come from that background, and I mean, if you remember, there used to be a time when everybody was talking about what is going to replace Java.
Exactly.
Java.next. I mean, there was even an acronym for it, and everybody was looking for what's it going to be. Is it going to be Scala? Is it going to be Groovy? And the answer was already clear. I mean, I think at that point you looked at the language and said, no, that's not going to be. Then even more exotic stuff like Clojure or things like that. And but there still was this idea that Java has to go. There has to be something else. There has to be like a version 2 of the main language and the JVM.
Well, the best argument, but I was really a little bit afraid of it. They say Java will die because Scala comes with native support for XML. And what I knew back then, that lots of my clients, they used ESBs and SOAP, right? And I say, if they notice that, right, and they build the first ESB in Scala with XML, this could actually be somehow powerful argument I didn't like XML at all. I tried now to completely ignore it, and but it's better than YAML. But still, back then it was overused, and now this was actually, I think even Sun, I assume still Sun was a little bit under pressure because they also try to justify why Java doesn't support natively XML. And I would say if you would support natively XML now, we would be in trouble. How to get rid of it, right? But this was like one of the arguments where everyone had to justify why Java doesn't have a language level support for XML. And Scala somehow had, I forgot what they did, but they had XML native support, no?
But the way you have to do it is like Kotlin does it with this DSL stuff, which is totally generic, and you can use it for your own purposes. Like when you program in Kotlin, you can program these little DSLs. You can make them up on the fly. It's very easy. So you have your own kind of builder thing where you can build a tree-like structure of stuff that is statically typed, and at each level you have various options, and you get them in code completion. So that's all very nice. And you have to, the way that Kotlin did it, I think, is pretty unique, and no other language really does it that way, statically typed language, and I think that's a big bonus. So, but still, I mean, you may say this is not enough. There is no real compelling reason we can still use the templating languages and so on. That's fine, and yeah, that could be right. And then there is the third big thing, where I would say that is really a reason to use Kotlin if you have that kind of project or that environment, and that is Kotlin multi-platform. And that's a big thing. That's a really big thing, and they pour huge resources into it. I mean, JetBrains is a fairly big company, but they really are going all into that Kotlin multi-platform thing. And I think that's a great thing to have, especially if really you need to be doing something on multiple platforms for that to be interesting. So like you're developing an app that runs on iOS and on Android, and you have a web version of your app as well, and then you have some server-side backend code, and all of that has to work together. And you can now bring this into a single language where you can share code across all these boundaries, where you can have common code that does things for all these platforms, and you compile natively to those platforms. So that's a really unique blend of ideas that they took there. I mean, you have other things that you say, isn't that the same, like Flutter or React Native? But it's not. Those are much more high-level things, and this is the Kotlin multi-platform is really about having the language that compiles down to these platforms where you can natively work with the stuff that's available, and that's a very interesting thing. And it went stable 2 weeks ago, I think. That's the 1.9.20 release of Kotlin, where they declared that it's now stable, can be used in conservative environments. So that era is just getting really started, and I'm currently working with it, and I think it's really great.
I like your argumentation. So what I'm missing on the server right now is JSPs, by the way, Java Server Pages. What I often need is just a simple, not on the server even, for command line interface, whatever. So it is somehow solved with text blocks a little bit, but you get crazy if it gets more complicated. You cannot just remember all the parameters afterwards. But are you aware of string templates, the preview feature in Java?
Yeah, that's also a good idea. Think of how they look at things, how they are in other languages in Kotlin, and then come up with a really good solution where they have everything thought out very well, and that's a great feature, right?
Because the string template, what they will able to do is this will be type safe. So they will be able to validate actually what you wrote in a string with as the template. So, for instance, it should be possible, for instance, to parse SQL statements if you write the stuff, and you could also the HTML. So this will be the solution to that problem. But what interests me with Kotlin is with the native stuff, or what you said, multi-platform, because Kotlin gets compiled to bytecode at the end of the day, right? So what they did, they are reading the Kotlin source and translating something directly, because if you compile it to bytecode, it should be also doable with Java, right? This is not like
No, they actually, to do this right, they rewrote. But what they have been doing for the last few years is rewrite the entire compiler and their entire internal stuff, and now they rewrite that to an internal representation. It's like an IR. It's just something Kotlin specific. And from there, that's something where all their compiler plugins work on, and then from there they compile it to the. So there's one level more in between.
Okay.
They don't compile the bytecode and then to the native stuff. They compile to their internal representation, and from there it goes into the backends. So that's different. So you could not like compile something with Java and then leverage the Kotlin compiler to produce native code. That would not work.
Okay, so the first time I'm with you, because now we are not talking about Java, we're talking about Kotlin with complete parallel stack to Java, right? So it's like, because there's nothing to do with JVM anymore in this particular case.
Right. The Kotlin language is not tied to the JVM. It's you have this specification, which is completely standalone. And you can, when you have a Kotlin multi-platform project, you have these modules that are called common modules, which where you don't have any environment, basically. So you just have pure code. So you can do like validation logic or stuff like that, or there is some stuff. They have a standard library. There's strings and even some kind of I/O. You can have like things like a byte buffer, and that's all like modeled a little bit after the JVM. So they come from the JVM and they take the JVM concepts and try to make them abstracted from the JVM. So you have these common modules. That's just pure Kotlin, and then you have modules that are platform specific and that can then depend on these common modules. So you can reuse the same code on different platforms, compile it down to different platforms.
So what it means is, would it be possible technically to run Kotlin natively? Let's say I target Mac environment. And I would write, to write with Kotlin a hello world, just to show something in my terminal, without any JVM installed, which has nothing to do with JVM. So I can just download Kotlin and natively compile it to Mac without any association with JVM OpenJDK, or I still have to have JVM and then Kotlin. No?
Yeah, you can. I mean, the Kotlin compiler is a JVM product. So the compiler is written is a JVM thing. But like the output, when you compile something natively for Mac OS or for Windows natively, it will be just a native executable. It will not
but this is like Graal, right? Graal VM is written in JVM, but the output is in native, right? So
yes.
But there's still Java. What I'm saying is, but I can download the Kotlin compiler, which is written in Java, but we can hide it. But I don't have to have JDK installed. So I don't have to have Java 21 or Java 7. This is
the difference is with Kotlin, you would be writing a native program. You would be writing a program that is a native, that's not using the JVM libraries. It would have to use the native functions that are available on OS. That's the difference. It would be really native.
So the only link to Java is the compiler, which can be hidden. It's just they decided to use Java back then to write the compiler, but they could write it with Kotlin right now. Right, would be possible, or in C, let's say they could write
they could use like rewrite everything in Kotlin native, but that like wouldn't make any sense because everything would be harder. Like doing things natively is a lot harder than doing things on the JVM. So it's better to be on the JVM for complex solutions, because that's like the best solution that there is. Things do not become faster. Like if you use Kotlin native, everything will be slower than having a JVM program in a sense, because the JVM is super optimized. There's all the library and so on. So that is not really like the idea. And I think the main thing for them to compile native code, the main idea is to be able to work on the mobile platforms, really, like on Android and on iOS, where it has to be native. You can't you don't have a JVM there. So that's the main thing. Like on the server side and on the desktop, producing native programs is possible with Kotlin multi-platform, but I don't see the use case really, because it's better to have a JVM project.
Because why I'm asking so in this direction, because I was always bored if Scala had to run on JVM. I was okay if I already have the JVM and then I need the Scala libraries on top of the JVM in order to talk to the JVM. I mean, I'm absolutely not interested. But what I, for instance, like is the language like Swift, right? So it is complete different stack, so okay, I'm with it because there are complete different possibilities. But running another language on JVM because we can, so okay, maybe, but why then, the argumentation starts with Java 21, but you are actually the first one who completely arguments in different way. Usually, they try to show me a feature, and I was bored because, okay, I see the point, but I mean, there was like suspended the coroutines, and I had the ASIC response for years in Java E, and I say, okay, I see this, but maybe I use it one time and not always using this feature. A similar feature is not the same, of course. What interests me in Kotlin is this one killer feature where I think it could take off, and this is Wasm. What Kotlin can do, and this is, I think, the biggest, I would say, danger to Java is because Kotlin can translate Kotlin code to a WebAssembly. And WebAssembly becomes interesting because Docker is looking at WebAssembly, whether they can run, WebAssembly natively on Docker. Kubernetes is, then all the edge computing devices are looking at WebAssembly. And WebAssembly is a little bit pity because for me it's nothing else than bytecode. But regardless, the Java bytecode is not, I would say, people associate Java with, I don't know what, with old AWT, which looks terrible, right? And therefore it is no more that hot as it was before. And they try to always, to reinvent Java, which is similar, but it's not called Java. And this is WebAssembly to me. But still, now it takes off like crazy, and Kotlin is able to natively support Wasm. It's still experimental, but it's interesting. And I would say this, for me, would be one of the killer features, and you are near of explaining this because you already told me, with the native and whatever. But all other requests, I have to say, project I found, which use Kotlin so far. They use, for instance, Quarkus, like, backend development server. So, and they use Kotlin, and I look at the code, and there was almost no difference. It was different to Java, but I couldn't understand what is, the advantage of doing so. Because in Java, it is not, I don't know, JAX-ORS and stuff like that, the add path and get. So if you write it in Java, it's almost no code, right? You have a method, returns JSON object, and it get. And with Kotlin, it was almost identical. I was okay, the syntax is different, but what is the advantage? And they couldn't explain. So never. So I look at the code, and this was like, this was the same what happened in Scala, whatever. They had a different framework, like Play, whatever. It was different, but I don't think whether it was better. And the first time I hear is the native, and this is where I see the point. If they are able to transpile Kotlin to this intermediate representation, IR, and then they have tooling, to distribute to different platforms, they can actually be better than Java because they don't have the limitations with backward compatibility, whatever. They can do whatever they like. And because JetBrains is capable company, I mean, they have, the meta programming environment in JetBrains?
Yes, the MPS.
MPS, exactly. So they were for 15 years with MPS. They could do, DSLs, code generators. So they are, I would say, the most capable engineers for building platforms right now. This is my opinion about them. So I think with the IR thing, they can be really capable, right? And Android, for instance, to my understanding is that Kotlin is the system language on Android. So the Android Studio, everything now, the way to go is Kotlin. And if they don't have Kotlin, they have to fall back to Java 8, I think. So Java 11 is still not there. And Kotlin solves all the problem. So I see the point on Android. And I always ask myself, what when Google says, okay, we don't like Java at all, and we have another, a native language for the Android, and then Kotlin dies on Android. Would it be still that popular? This is the interesting part, right? So this would interest me. What if Google says, we don't like Android Kotlin anymore because it's somehow associated with JVM? And we would like to use the Fuchsia, or whatever called the operating system, with the language what I forgot, probably Dart, I would say. Dart, Dart, and then it's over with Kotlin on Android. So now the interesting point is, will Kotlin be still as popular as it is right now? So strategic question, right?
Right. I mean, of course, a lot of the Kotlin popularity and the developer base is in Android, but I think this is like not. It's not overwhelming. There is a large portion of developers who are using it on the server side as well. Mm-hmm. And the multi-platform stuff is just getting started. I think that's
Okay.
not yet a main thing. And if you think about, it's very interesting if you think about like other systems which are similar. And the other system which is very similar is the idea that you take JavaScript, which runs on the browser, and then also run it on the server to have this common multi-platform thing where you can shift code around. And I think it was Netflix, or they pushed that and developed that because that was important for them to have this flexibility of doing sometimes things on the server or sometimes in the client or in both of them together in a hybrid way, and that is the solution that comes from the front end and goes to the back end. And with Kotlin, it's the other way around. You say you have something that comes from the server side and pushes into the front end, and so to have this unified environment. And it goes even further then because like it's not, or originates from the browser and is not so much tied to these concepts, and then can push into all the platforms natively. So but I think that's those are the two main multi-platform things. Is the one is where you learn TypeScript and then can write on the browser and write on the back end, and the other thing is where you write Kotlin and can also do the same thing with a focus on the server side and not so much on the front end side. And those are the two main things. And the TypeScript Node.js, that's already very well developed, and there are lots of developers like who work in this full stack environment in that way. And with Kotlin multi-platform, just getting started, and we'll have to see how much mind share that will get and how many people will jump onto that train. And I think that could become like a defining feature for Kotlin. Also with the things that are coming, like they're developing something that I also find very interesting, which is a new cross-platform UI toolkit. It's called Compose, where you can write UI that will then work on the web, on the desktop natively, on the JVM, on the various mobile platforms. And that will be like a super cool thing. Like all these multi-platform libraries that they have, where you can then say, I apply this library, and then it has native implementations for all the various backends. And
this is actually what I looked at use a bit, because it's very similar to Swift UI, and we had to do something on Android. And this Compose is a reactive, where you have a declarative UI, and this is driven by a model, and every model change reflects in the UI. It was like a preview last year. I think now this. It is really interesting. So, what interests me? What is the commercial interest? I think the commercial interest is that the IntelliJ or the JetBrains tooling is used more, right? So this.
But of course, at the end of the day, you will have to use one of their tools. I mean, of course, you can use something else, but it will be a lot worse. So
yeah, this is why I tried Kotlin with Visual Studio Code, and it was not that good, I would say.
No, you wouldn't do that, really. Yeah. So you have to use one of their tools. Actually, now there will be, I think, really two options, because either you use the IntelliJ or the new one, the Fleet.
You tried that, the Fleet?
Yeah.
I tried that, but I have to say, it was... The experience right now was not good, because whatever I tried to do, it downloaded first, whatever to need to download, and in the end, it was significantly worse than IntelliJ, but even worse than Visual Studio Code. So this is right now. But and what also I'm really interesting with the Fleet is, they are competing with Visual Studio Code, and Visual Studio Code is huge. So I have to say, everyone uses Visual Studio Code except a few Java developers use IntelliJ, right? So you shouldn't underestimate the Python, JavaScript in the entire ecosystem. This is a huge ecosystem, and Microsoft pushes like crazy. Everyone who uses GitHub uses basically Visual Studio Code. So I'm interested in what happens to Fleet, because if Fleet looks too similar to Visual Studio Code, this is a little bit my problem, right? So IntelliJ is okay because it's different, and I would just push for it because it's like expert tool. But the Fleet, I don't know whether it's the right direction, to compete with something which is that similar, right?
I don't know either, really. I have no opinion on.
You tried that with Fleet?
Yeah, but still, I mean, I would not use it. I would use.
Yeah, exactly.
That's my tool. That's my environment, and I think I don't see the advantage really.
Yeah, exactly.
The Fleet style environment, but still, they're pushing it for it hard. I think that's not something that they will give up on, and they already have things like they want to have this Kotlin multi-platform thing in Fleet.
Okay.
That would be one of the things that they want there as a big feature. So that could be a reason for people to use Fleet and not Visual Studio Code.
This is what I understand. Then is the strategy brilliant, right? Because if you're targeting the Visual Studio Code developers and you offer them alternative, which is not Java, it should not look like JetBrains, IntelliJ. It should look like Visual Studio Code, but they get a nicer experience, this Visual Studio Code with JavaScript. Then this strategy is brilliant. So they are not targeting Java developers. They are targeting whoever uses Visual Studio Code right now and hope it could take off.
Yeah.
Yeah, this makes absolute sense because I say, yeah. Interesting. So what is actually your reason now to use Kotlin? Just to have a type-safe HTML?
Right. I mean, I have the type-safe HTML, and I have the Kotlin multi-platform. So, like, when I don't write JavaScript, I really don't like to write. I wrote a lot of JavaScript in my life, and I have never gotten around to liking it. And I always thought I could learn TypeScript. That would be nice, and TypeScript looks good. But I don't use it often enough. I don't think I would get into a state where I would use it and be really proficient in it. So I always decided not to learn TypeScript, really, just apart from doing some basic tutorials. And so I don't have to write JavaScript anymore. I can write Kotlin.
Okay.
And then I have the added benefit that I have these common modules where I can share constants, logic, even rendering stuff. Like I render stuff on the server side, as I told you before, with the Kotlin DSL for HTML. And I can move that, because that's a multi-platform library, this HTML rendering, I can move that to a common module. And then I can have the same rendering on the server side and on the client side, which sometimes is necessary. When you dynamically produce like additional UI, you have that, it's completely fluid and it's all tied together. There's no boundary where you say, okay, where does that come from? What server-side method is this? You can always follow by clicking in the IDE through to these constants to the source. And
this is huge. For instance, what we did with it with similar technology, you remember Nashorn, right? And it was JavaScript engine. And what we did, we reused the validation logic in client and server, right? Because if you have an input field form, and you put something to text fields and you validate it as JavaScript, but you have to revalidate exactly the same way on the server. So on the server in Java, we use Nashorn to load JavaScript, the same JavaScript which was shared between client and backend to have the same validation logic. So if Kotlin does it, out of the box with a common module, I could write, validation logic for bigger enterprise projects in Kotlin. And then, and then have the same validation in front end, in backend, which is a huge advantage. And because it's Kotlin, so it means it is supported by a single company without external dependencies.
Absolutely. You don't have external dependencies. It's all there. And it compiles reasonably well to JavaScript. So you have this Kotlin code and it compiles it. There's Webpack is included. It minifies everything together already, and it's pretty okay. So you get small output files, relatively small output files, and you don't have to write JavaScript anymore. So this, of course, for a JavaScript developer, not interesting. For a TypeScript developer, it's not interesting. But for somebody coming from the server side who wants to do stuff on the front end, it becomes very pleasant. It's very nice for me to work in a browser environment now, which used to be I always thought, oh no, like then I don't do certain things because I think this is risky. Let's leave it that way. Who knows? And then maybe it's not working on Chrome or on Firefox or whatever. And in this way, you have this completely type-safe environment where you only can call things that really exist and are part of the standard DOM, and you have your environment where you can work productively and not like feel not at home. Yeah? You feel at home on the browser immediately. That's for a server-side developer. That's a big bonus. Makes you productive on the browser immedially.
What really described with the Kotlin from backend to frontend, it reminds me a little bit of Vaadin. You're aware of Vaadin framework?
Yes, I am aware of Vaadin. I did a lot of work with Vaadin, and but that of course is different in the sense that Vaadin has the browser as a sort of as a terminal.
Yeah, exactly.
You don't really have any code on the browser. If you want to have your own code, you have to write it it used to be in Vaadin 8, and before it used to be GWT, so you had to
Yeah,
write it
terrible.
in Java.
Yeah,
GWT, which has a steep learning curve, you have
yeah.
to learn about GWT.
And it's slow for compilation. It is not good.
It takes a very long time to compile stuff for GWT and debugging and so on. Everything is harder. And the new Vaadin uses TypeScript in the current version. You write client-side stuff in TypeScript, and they have now this hybrid business model where they sell components to JavaScript developers, and they still have this terminal type. Everything is on the server side, and you don't really know anything
Yeah.
about the browser, and you have just our own API. You make a button and then add a click listener to it, the swing type
Yeah, exactly.
thing, and so on. Yeah, but that's good for some.
But it's similar. Just what if from conceptual is kind of is like a remote control. Yeah, the browser is remote controlled by the server more or less, and
You have a single module there in Vaadin. You have just one thing. There's not multiple. There is no boundary between layers, really.
Yeah.
That makes it even more abstracted, which makes you more productive. But once you need to break out of this model and do things, then it becomes a lot harder, and then you have a lot harder problems to solve that you would otherwise be able to do very easily. And with this Kotlin multi-platform, you have the boundaries. The boundaries are there. You have the back end, you have the front end, just like it is really in the real world. But you have the single language that can bridge these boundaries. Like, for example, you have a multi-platform library that's called Kotlin serialization. They have this serialization in Kotlin where you can then serialize stuff, a complete graph of like Kotlin objects on the JVM, serialize them to JSON, and deserialize them on the backend. And it's all transparent. I mean, you don't. That's things where you could use other frameworks to generate stuff for you, like JHipster or so on. But it introduces a lot of other complexities. Here, you just have the single language. You serialize it through. It comes out on the other hand. The classes are in the common module. They're available both on the server side, on the client side. And makes it very easy.
So you have three projects, right? You have a front-end projects, common, and backend, and three modules, Gradle modules or whatever.
Right. So the way it works in Kotlin multi-platform is really that in a single module you can have these multiple source sets that live in the same, and you have to use Gradle. I mean, there is no Maven thing. It's a Gradle thing. Yeah.
Which is okay because in Android is mostly Gradle. I mean, this is where it comes from.
Yes, that comes also from that direction. But then you basically apply the Kotlin multi-platform project, and then you declare your source sets. You say, I have JVM, I have JS, I have WASM, I have Android, I have iOS, and you could have different architectures and so on. So you get this tree of source sets with common source sets in this ancestor hierarchy where you could place the common code, and then it gets compiled down to the actual leaf platforms. But it can all be in a single project, so it's pretty easy to set up, and the dependencies are there automatically. So like the JS part and the JVM part would automatically see the common code.
Mm-hmm. But the Kotlin front end is automatically transpiled to JavaScript, right?
Yes, that would be like you have to declare like that you want like binary output, and then when you run the task, it will produce this JavaScript.
But how you run your backend now? So I mean, you start just Kotlin main, or what happens on the server for your string for HTML templates?
Oh, let's say you have a Spring Boot application.
In your case, you are using Spring Boot.
Yeah, in the Spring Boot application, when you have the controller, like in MVC, not in traditional MVC, you have a controller, and what you would do, like before, you would return the name of the view. Mm-hmm. So that Spring then could find the view and pass the model into it to produce the output. And right now you would just like directly, with a direct invocation, invoke your own code. You can put it somewhere else, call it a view, and then render this as a string and return it as a string or as a response entity of string. That's this direct thing. There is no more gap in the sense that the IDE would have to help you. How do you get to this? You just click on the class. It's right there. So it's a direct thing.
Because in my world, everyone uses Quarkus with Kotlin. It's also very good Kotlin support. It's similar to Spring Boot with JAX-RS. But what I surprised is there should be a native Kotlin framework, right? For the backend. So why you are using Spring Boot with Kotlin? Why they don't? I mean, it's not that hard. Yeah? They should have a native Kotlin something backend server written in Kotlin.
I mean, there's lots of options. You could use Kdor or
exactly. Why not using this?
Why am I not using this? Because this is a historical thing. I'm coming from Grails. Grails was based on Spring. There was always the Spring layer below the Grailsy stuff. It was always there. So in a sense, it used these concepts. And there was a migration path where we could migrate the Grails backend with all the Groovy code to a Spring Boot application where we then basically translated all the Groovy code into Kotlin. That's what we did. So we got rid of all the Groovy code. We were unhappy with the Groovy code.
And you have lots of code, backend code? Is there lots of code you have?
Yeah, so like our e-commerce backend is pretty extensive. It's a really a medium-sized application. It's not small. We do lots of things, and we do all of it by ourselves. And it's important for us also, like as a profiler vendor, it's important for us to do server-side development ourselves. We have to, because that's like most of our customers are doing server-side development, so we have to do a little bit of that ourselves as well with databases and stuff like that. And so we always did that. Right, so that was the reason. We came from the Grails world, and there was a migration path into Spring Boot. And Spring Boot is something that we will naturally also choose to say this is like the most important of these technologies in the sense that most people use it.
What interests me is if you run Kotlin, let's say, on Spring Boot, or you use Spring Boot without Kotlin, and you fire up the JProfiler, is there any difference? So is there any performance impact in both directions using Kotlin? Maybe not, right? This is depending on which APIs you are calling. Would be more interesting to have a native Kotlin application, right? And profile this. So
well, that you would have to have a native profile then.
This is
in the sense that Kotlin from Kotlin code, it produces bytecode that is similarly efficient than what the Java compiler produces from Java code. I mean, there's some language features that have to be where the compiler has to add like this syntactic structures, has to generate some code and so on. It could be a little more code than you would get if you write something in Java, a little more bytecode. But generally, there is no performance problem, or the performance is equal with Kotlin code compared to Java code. That's not the thing. And if you profile it, for example, then of course it's a little worse than writing Java code, because the Kotlin compiler will add more synthetic methods and stuff like that than the Java compiler does, because it's language features which are more complex in a sense and have to be implemented in some way. So like analyzing stack traces from a Kotlin program is a little worse than analyzing it from a Java application, but it's still okay. I mean, like when you look at other languages that are on the JVM, then it's excellent. So you can still have a reasonably close. The JVM execution is reasonably close to what you write in your source code, and so the profiler it's a good experience if you profile Kotlin code, as opposed to profiling Groovy code, for example, which is not a good experience.
And do you have any additional Kotlin support in JProfiler, or is it just stock, or you think about features you could build into JProfiler right now, or?
Well, I mean, what we really display, what we do have, of course, we have a big specific Kotlin feature, which is support for Kotlin coroutines. So what you want there is to get a single call tree, because it's like running on a lot of threads, and you just get snippets here and there. You don't get hotspots in a meaningful way in such a system like with coroutines. And the profiler has to do that, has to be able to understand, and that's actually a big feature. It took us a long time to get this done. So you can like go to the call tree and say inline all the asynchronous executions, and then we'll build a call tree that is understandable, where you can see the points where control was yielded and so on. You have this unified view. This is a call tree analysis. So if you go into JProfiler, you say analyze, and then there is this inline async executions, and that has support for Kotlin coroutines, among other stuff like executors, for example. Java executors could do the same thing, where you could just push the execution to other threads and have it fragmented in the same way. But Kotlin coroutines is supported. And then, of course, we support the source code navigation into the IDE. That's an extensive thing where you have you see something in the call tree and say, show me that in the IDE. Then the JProfiler plugin in the IDE, in IntelliJ IDEA, has to understand how to find the actual location in the source code. So we do that as well.
What I wanted to ask, just thought about the support for Kotlin inside the your JProfiler, and what I also thought immediately is about stuff like virtual threads, for instance. So if let's say the JVM pushes forward, so we have JDK 21, 22, 23. This could be a bit of danger if the features start to overlap, right? So if, let's say, Kotlin uses feature which is not compatible with Java standard, right? They cannot use it natively anymore because they implement it a little bit differently. But I think that the Kotlin engineers are following Java closely, maybe even work together with Oracle. And not that happens, because I think it happened in the past several times with Scala and other languages where Scala invented something and it was a little bit different in Java then, right? So, yeah.
Yeah, it is, of course, like with the coroutine stuff, that is something. But I think they will just leverage the virtual threads in the futures.
And so what we have a big surprise now to listeners. So what you were able to do is to set up a coupon code, right, for the listeners, so they get JProfiler for a special price, especially if for all Kotlin friends as well. So not only for Java developers, right?
Yeah, that's right. Yeah, that's so until the 1st of December, we have here for the listeners of this podcast a special coupon code. And you can enter that on the website, and you get a 50% discount on all products. And the coupon code, I chose one which is easy to remember and to understand here, and it's just Java 2023.
So Java, not Kotlin, right, for the listeners?
I chose Java, not Kotlin. Java 2023. It doesn't matter if it's capitalized or lowercase. So that's the coupon code, and it will be valid until the 1st of December.
And the website is EJ Technologies, right?
ejtechnologies.com.
And it looks not that great, not as good as a profiler, because it's written in Kotlin, right? So this is the reason.
Not yet. That's a new website that I'm currently writing. So that will look a lot better.
Okay. So what I'm a little bit disappointed that you're not using now Kotlin full stack, that you rely on Spring Boot. So I mean, it would be a lot of work now to convert. What's the problem? Why you couldn't use now the native Kotlin framework entirely?
Well, then there are several options. You would have to choose from them, and as I said, I really I'm not averse to using Spring Boot, also because a lot of our customers, like I see, there is a lot of Spring Boot usage. People, and so I think it's better for me to use some industry standard type tool than try to find something which is like important in Kotlin, because that's still not as important as Spring.
What happens a lot actually after WJack's talk last week? No, this week. I got attendees came to me afterwards and say, how can I use more modern stuff? And what really happens a lot, not because it is better, is because it starts faster, Micronaut and Quarkus. I think you could look at this. Have you tried that?
I've looked at these things, yeah.
And you know what they are doing? What the only difference is maybe, I don't have a lot of experience with Spring Boot, but the difference to application servers, which are similar to Spring Boot, is that Micronaut and Quarkus, they build everything up front, and they remove reflection and configuration parsing at runtime. So, and what this leads to, stupid bytecode without any reflection is just everything is hardwired, in incredibly fast startup times and less memory consumption. And you can say, no, what? Because if you run your e-commerce system, it doesn't matter for you. But what happens in my projects, we are more or less forced to use Micronaut or Quarkus, because if it starts faster, my clients pay less. If you are in the cloud and you write serverless applications, the memory and this is why I do Quarkus everywhere. And Micronaut I could use. You would like Micronaut better because Micronaut is more compatible with Spring Boot, and Quarkus comes from my direction, from Java EE and J2E, but and it's more microprofile compatible. But at Devox I had a chat with the Micronaut people, and they say okay, they will also push more microprofile compatibility. And it is similar to Spring Boot annotations. It is like this entire Java and Java EE world is compatible with Quarkus, and this is what I was surprised that you actually because you should at least try it. And in your case, I would just go Kotlin full steam ahead because fun. But Quarkus and Micronaut, at least try one module. I would say for you would be both, because actually the ecosystem of Quarkus and Micronaut is huge. I maybe after the recording I can tell you what happens really. So it is really big projects are developing right now just because of cost savings. This is the only reason. It's not like this is better or worse. No one cares about better or not. It starts faster, consumes less memory, period. And now with the Lieferketten KSG Gesetz and CO2 consumption becomes also more and more important. So it is it could be interesting to you. I'm just saying, right?
Yeah, and these things are very interesting for me. Everything we constantly look at all sorts of technologies. Also, because we have to be able to deliver a good experience with the profile. So we have to proficient in a lot of these technologies, and they're really very interesting. In terms of I could use other things for my backend, but of course there's always a migratory cost that is substantial. That's for an existing project.
But if I do something for me, right? So for myself, I also have my server and my infrastructure. I experiment a bit more, and I'm willing to push forward. Also, it makes no sense from the commercial perspective just to try new things and learn things. On my client's side, I'm more conservative, but for boring projects on my server, I'm a bit more crazy. But yeah, it was actually nice. What's the progress of Visual Studio Code actually? So can I just use Visual Studio Code with JProfiler?
Well, I haven't gotten around to that yet, but I promise you I will do that in the near future.
Okay, because what I thought about this is what Visual Studio Code can do. Maybe I mentioned this already, and I do this actually all the time. If I'm reviewing a project for my client, I open Visual Studio Code, and it parses very fast without Maven or whatever, the Java code, and it can even navigate it a bit just by opening it, right? So if and this would be big for profiling, because if the profiler connects to the code, and I could navigate the code in Visual Studio Code without building it, because some of the dependencies are in Maven repository or whatever, so I don't have access to everything, but at least the high level code, it would be already a good feature. And this lightweight mode in Visual Studio Code is actually a big feature, because it doesn't have to understand Gradle or Maven, just opens Java and parses Java like a Java parser, right? So this was the And to the listeners, if they go to the EJ Technology page and you see, some boring Kotlin code, I would say Kotlin design, I would say, just you have still to download JProfiler. I just did it, and it was it looks great and it behaves great. Just as a message, the JProfiler is worth trying. I just saying because I was pleasantly surprised actually, and I always like good Java tools. So I try, this Fleet or whatever, Visual Studio Code, because I like, to try out things. And JProfiler was a pleasant experience. So to all listeners, at least you have to download the J profiler and try it, right, as a profiler. And connect it to Quarkus, let's say. Maybe it will also work with Spring Boot, who knows, but I had good experience with Quarkus.
That's very great. Thank you.
Thank you. So EJ Technology. So Ingo, see you next time. If you have Visual Studio Code support, I will re-invite you back so we can talk about that. So this is like, this is now your, and then we can promote your J profiler as to give back something. And yeah, maybe. Thank you.
Thank you, Adam. Thank you. Have a good day.